Hello students, hope all of you are doing great at home. And hello students, now today we are going to start the new chapter, that is atoms and molecules. And students, this is very interesting chapter. I hope all of you will enjoy studying this chapter, students. And today we will start from this chapter. And before this one, student, during last chapter we had discussed the different classification of matter, and that were solid, liquid and gases, and also we have discussed the elements and compounds. And student, we had discussed that element, that is compound, has formed from the different types of elements combining together in a fixed ratio by mass. So students, here how this compounds has forms, and how all the different type of metals are formed in this world, we will discuss one by one in this chapter, students. So students, we come to know that atoms are the basic constituents of matter, or atoms are the fundamental units of matter, and different substances, students. So different behaviors because of the different in the composition, structure and properties of the constituent particle of matter, and these constituent particles are atoms and molecules, students. So students, the Maharishi Kanad was a person, one of the first person, student, we can say, to propose that matter is made up of very small particles, and these particles were called Parmanu by him. He said these particles as Parmanu. And John Dalton called these particles by the name of atom. And another, later on, after progressing some later, another Indian philosopher, student, that is Pakuda Katyayama, he proposed that the particles of matter, they normally exist in a combined form, student, not in free form. They exist in a combined form, which is known as molecules, students. Yes, student, one thing, that is atom. Atom, actually this word has come from a Greek word atomos, and that means indivisible. So according to them, at that time, the scientists said that atoms are indivisible. But student, we know that human, they are very curious to know about the matter from ancient time, and they have done many experiments, and after a lot of experiment, that is they have come to another conclusion, and day by day still we are just we are improving our science, and new theories are coming nowadays. So all the ideas of the atoms, which on the basis of which they used to say that the atoms are indivisible, they were actually based on philosophical consideration, students, without validating them experimentally. But by the end of the 18th century, a scientist recognized the difference between elements and compound, and Antoine Lavoisier, student, he was the first scientist who proposed the law of chemical combination. And with the help of these laws, the phenomenon of combination of substances can be understood, student. And these law of chemical combinations are of three types, student. These are conservation, the law of conservation of mass. Second is law of constant proportion, and lastly the law of multiple proportion, student. But out of all these, we will have to study only conservation of law of conservation of mass and the law of constant proportion, student. And this one, that is law of multiple proportion, This is not of this level of class 9. This one will be studied later on in higher classes, students. First, we'll discuss the law of conservation of mass, student. So for this one, student, first of all, we'll know that who had given this law of conservation of mass. The law of conservation of mass, actually, student, it was given by Antoine Lavoisier. First time, student. He was a French chemist. Okay, sorry for the light has gone actually. So because of disturbance, it is there. So student, Antoine Lavoisier was the first person. Actually, he was the first person. He had a French chemist, and he had given this law of conservation of mass in the year 1774, student. And because of his contribution, student, he is also considered as, he is known as the father of chemistry, student. So in law of conservation of mass, what does mean by it? So law of conservation of mass means that in a chemical reaction, student, the total mass of the products is always equal to the total mass of the reactants. It is always equal to the total mass of the reactant. That means there is no change in the mass during a chemical reaction. For example, if here A plus B, that means these are the reactants. What is reactants, student? Those chemical substances which take part in a chemical reaction is known as reactants. And those substances which produces during the chemical reaction, the substance produced during a chemical reaction are known as products. So here in this, student, the total mass of the reactant and the product including it includes solid, liquid and gases, student. That is total mass of the reactants, whether it is reactant or products. So it remains always equal, student. The mass of the reactant is always equal to the mass of the products, whatever products has formed. If we'll get the sum of the mass of both the product, and if we'll get the mass of both the reactants, and then if we'll conclude, we will find the mass of reactant will be definitely equal to the mass of the product, student. For example, we can take here example, and that is here student, actually let me arrange it. It is not appearing clearly. So yes, student, here see, here in this example we can take one example, that is if we'll burn 12 gram of carbon, that is it is suppose it is coal or coke is the pure form of carbon. So coke, if we are burning 12 gram of coke in 22 gram of oxygen, so it will, student, get converted into carbon dioxide of 44 gram. So here total, if we will include both the mass of carbon and mass of oxygen, total 12 plus 32, it is 44. So 44 total this side, and this side also, the 44 gram of carbon dioxide will form. So student, from this we conclude that the mass of reactant is always equal to the mass of the products. Now we conclude that since the total mass of product, that is carbon dioxide, is here 44 gram, and that is equal to the total mass of reactants. Here reactants are carbon, whose mass is 12 gram, and oxygen, its mass is 32 gram. So 12 gram and 32 gram, that is 44 gram. So both the products, mass of the product and total mass of the reactant, both are equal. So that means there is no change of mass during this chemical reaction, and the mass remains the same or conserved, and thus So what we conclude that the mass can neither be created nor destroyed during a chemical reaction. Okay, student, for today, and thank you for watching this video, and stay home and stay safe.